Hello everyone, welcome to this tutorial. My name is Emerson Ahrari, I'm a Google Earth Engine expert. In this tutorial I'm gonna introduce one of the important products produced about or recently published about the agricultural studies in awesome Google Earth Engine community catalog. So this product is a kind of Landsat-derived product allowing us to discriminate the rain-fed and irrigated croplands. That is very awesome and also incredible, and it really facilitate the studies on agricultural area. So now in this tutorial I'm gonna show you how to work with this product and how to get relevant information for your own study. So in the first step, you can find this product from the awesome Google Earth Engine community catalog. The dataset link available below this video on my YouTube channel, and you can reach out to this page and get more information about this product. Here there is a Earth Engine snippet, just you need to copy and paste it into your code editor. In this tutorial I'm going to use the JavaScript for the Google Earth Engine tutorial because we don't have a focus on the machine learning or machine learning related analysis. That's why I have only focus about the data introduction, how to get the export and how to convert to the shapefile or these things. So we can do all of these steps in the JavaScript without any challenge. So back to the code. After you paste the code in the editor environment, now we need to make a mosaic of this layer because this layer actually has a frame structure separated for different region. So we need to make a mosaic from all existing images here. Then to do the visualization, use the map.add_layers. Map.add_layers, just like this. Let's change the layer name to the cropland. This is easier to remember. So cropland, and then I'm gonna visualize it through the minimum and maximum value. Remember to cite this data if you want to use this in your research or your project. And also here there is a data table or table content, a table that's containing information about the band values and also relevant information. There is a one single band ranges from 0 to 3. Each value shows a kind of information. For example, value is 1 non-cropland, value 0 ocean, value number 2 shows the irrigated cropland, and 3 the rainfed. Number 2 and 3 are the most important one, but for the visualization only range the values from minimum to maximum. The layer name here is cropland, and use the false at the end to avoid automatic visualization. Let's run a code. Once you run a code, after a few moments, go to the layers. Cropland is available. This product available in global scale, and you can use this information for your own region of interest. This is really incredible things. And also you can do a lot of research on different agricultural area, whether it is rain-fed or croplands. And you don't need to identify the croplands because the croplands and their type by the also their type already identified and detected in this product. You just need to call the NDVI and related data to get information about the croplands and agricultural area. So, for example, I'm gonna work on Iran. My own study of my own country is Iran. Now, same as the other studies, I'm gonna select a part of my own country to do the further analysis. So, now I'm gonna call the basin layers and then select the basin in the country and then make a clip and clip the cropland based on the basin and show you how we can download the cropland layer for our own study area, and then how we can get the NDVI series and another information about this product. So go to search places and dataset. In this step I'm gonna find a study area through the Hydro Atlas layer. If you type about the hydroshed or hydroatlas, you will find the hydroatlas basin layers in different scales. Lower values, actually greater basins included greater basins. So, for example, basins level number 5, consider it here. And now I'm gonna visualize all the basins through the map.add layer. Map.add layer through the table, and left the visualization empty, and the layer name is basins, and use the false to avoid automatic visualization. After a few moments, another layer added in the layers. This is basins. You can see all the areas, or all everywhere with the basins border. For example, I'm gonna select the Urmia basin in the north to west of Iran. So if you want to select the basin, just select it through a marker. Mark it through the marker, and then filter the basins based on the marker. So here, for example, I have an ROI, or region of interest, equals to, so from the table hydro basin or hydroshed, I'm gonna filter one basin, or bound it to the geometry. The marker already named as a geometry here. So now I'm gonna convert it to a simple geometry by the dot geometry, and then to speed up the processing, I'm gonna do the simplification by 1000 degree. So let's visualize the output, or the region of interest. Leave the visualization parameters empty, and here is Urmia basin, or ROI basin. It is easier to understand for you. You can choose your own study area or your own basin. You can actually use the basin borders or administrative borders. No matter, it depends on your target of study. So the ROI basin, and use the false at the end. So let's save the code and run it again. After a few moments, a new layer added, ROI basin. There it is. If you want to have focus on the study area, it is very easy to do. Just try with map.center object with focus on the ROI. There it is. You will have focus on your own study area, and then you can see the border shapefile. So in the next step, I'm gonna actually clip the cropland based on the ROI region. So map.add layer, here it is, and get the cropland first and clip it based on ROI. So remember to set the visualization parameters such as minimum and maximum value 0 to 3, and then the layer name is, for example, ROI cropland, and use the false at the end. Let's run a code. Here you can see the cropland for your own region of interest. So now in the next step, I'm gonna show you how to get export from the cropland map. For example, imagine that you want to get export from this raster layer for your own study area. So it is very easy to do in the Google Earth Engine platform. So we can do this through the export image to drive. Couple of arguments necessary to consider for the export or getting output here. The first one is a kind of image you want to get export. This is the cropland layer that is clipped based on the ROI, just like this. And the next parameter is about the description. The description refers to the name of the output. The output name is cropland for ROI, or region of interest. The scale of output, for example, I'm gonna get export as fast as possible, and that's why I prefer to set 100 meter as a 100 meter as a pixel size for the output. As you can see, it is mentioned that the output layer resolution is 30 meter because it is a Landsat drive, but I'm gonna get export really easy, and also without any time consuming process, because this is a tutorial, and we don't want to spend a lot of time to wait until an image get export. That's why I set the 100 to speed up the processing here. But if you have time, feel free to set the 30 for your own work. So, and the next parameter is a region of interest, or the geometry. Sorry, it is not the geometry. It should be the region here. The region should be set to the ROI and the CRS, the coordinate system, EPSG 4326. This is the WGS 84 code that is unique and same for all around the world. So, and the next parameter, the maximum allowed pixels for the output, 1E13 should be, and the next one is the target folder to get to save the outputs in. So this is the test. Let's run a code, and after a few moments go to the task in the right panel, and here it is, the Cropland ROI is available. Just click on run and then run. After a few minutes, maybe 5 minutes or less, you will have your output will be ready, and you can download it from your Google Drive. So that was the first step. Until you learned how to call the cropland layer, you learned how to identify the region of interest, and then you learned how to clip your data based on your region of interest. Okay. And in the next step, I'm gonna show you, for example, how to convert, for example, a part of this layer, a part of this area to the vector layer. Imagine that here, this region covered by irrigated land, and I want to convert it to a vector layer and get export. These are some questions that you may have when you deal with such kind of data. Converting to the vector is another target, or a second target in this tutorial. So let me to make a new geometry, and then I'm gonna select a region in which I'm gonna do a conversion, raster to layer. So go to the rectangular structure and select your area. For example, this is my area, and as you can see, this area actually including the irrigated or the rainfed, but I'm gonna have the irrigated lands for now. So make a new variable. There it is, a new variable created. This is the irrigated, sets to get the cropland layer. As you can see, values number 2 refers to the irrigated croplands. Select the values number 2, and then dot self mask help us to get rid of actually non-irrigated area. Let's do the visualization to see how irrigated area looks like here. Irrigated area that is clipped based on ROI, and then the layer name is irrigated, and use the false to avoid automatic visualization. Let's save the code and run it again. After a few moments, the irrigated layer is available. As you can see, all irrigated lands selected here. But I'm gonna do the conversion raster to vector for this area. This is also very easy to do. So let's follow this step. Irrigated vector is another variable here. Irrigated vector layer. So equals to get the irrigated layer, and then use the reduce to vector command. The reduce to vectors. So for which region? The geometry sets to geometry number 2, the green rectangle. And the scale size, for example, I'm gonna do the conversion based on 100 meter pixel size. So there it is. Let's visualize the irrigated vector. Irrigated vector, just like this. Leave the visualization empty. Irrigated vector, and use the false. Something's wrong, there is a typo. So here, this is the irrigated land, and also it is a vector layer. All irrigated pixels, or all pixels labeled as irrigated, now converted to a vector layer, and now we can get export from the vector layer. So as you can see, after 4 minutes the cropland ROI is ready, and you can go to the Google Drive and download and open in your desktop software. It is very easy to do. So go to the open drive, go to the drive, the corresponding address, the cropland ROI is created. Let's click on download. After a few moments the data download started. So set an address and data is downloaded here. Just go to the QGIS software or any other GIS related software and bring the downloaded area and do the visualization there. So the Google Earth Engine output for the raster layer, including the GOT format, and also you can open it up in all GIS related softwares and there is no limitation. So I'm waiting until QGIS comes up, and then we can do the visualization for the raster layer. But I think until then we can actually show you how to get export from the vector layer. So export table to drive. The export table is specifically used to get the export for the tables or the vector layers. So the collection, the target vector layer is irrigated vector, and the file for the description, the output name is irrigated vector layer, and the file format should be SHP. Let's run the code, and now irrigated vector layer is ready to run for the saving process into the Google Drive. The QGIS came up, and now I can show you the output, how the output looks like here. So in the QGIS upper left there is a button about open data source, and now select on raster because we want to open up a raster layer. Go to the address in which the raster layer stored. For example, the cropland ROI, it is my data, and now you can see the raster layer with the original values showed up here, and you can discriminate the different pixels with different values. Gives you a lot of information about the cropland situation in this study area. This is very useful process and technique, and it is already clipped based on the region of interest very well. Okay, back to the tutorial. An irrigated vector is ready to download from the Google Drive. Just go to the Google Drive account, and then now the layer name is the irrigated vector, and now I'm waiting to see where it is. In my drive, irrigated vector is available. A couple of systematic files are available here. Select them all together and click on download. After a few moments the process of downloading started. It is a zip file, and now click on save. The data downloaded successfully. Go to the drive and extract all. You can see the data is available here, and we can open it up into the QGIS. So now go to the open data, this time vector tab, and go to the address. The vector layer is available. Select the SHP layer and click on open and close. As you can see, in addition to the layer, actually the vector layer for the irrigated area also downloaded successfully, and now you can use this kind of export for the rest of analysis in the GIS related softwares. Okay, back to the code. Now imagine that we want to actually do this. We want to use the irrigated vector to estimate the NDVI variation through the time. Imagine that you have a study area, a part of irrigated land, in the croplands, a part of irrigated area. You want to actually see how NDVI varies in this region. So it is also very easy to do. Just make a new variable for the NDVI data. Go to the search places and dataset and try to find the MODIS NDVI products. Different MODIS NDVI products available. For example, I prefer to select one of them with higher spatial resolution, 250 meter with 16 days interval, less affected by noises and cloud cover. Import it into the code. It is available as an image collection. So set the image collection into the NDVI and set a filter date, or filter your data to a period of time. For example, the last 5 years, consider it as a period of time in this tutorial. In the next step, I'm gonna select the NDVI image and do this and apply the scale factor. If you go to the data characteristic, go to the bands, here you can see the NDVI is available with this scale factor that should be applied on data before further processing. So now make a map or make a loop structure, define a function inside the loop structure. Each input image consider it as an IMG here, and now that the image collection returning for example each image while NDVI already selected and scale factor already multiplied, just like that. Remember to keep the properties of inputs for the outputs through the img.property names, just like this. So now in the next step, I'm gonna get NDVI variation only inside the vector layer. Make a new print, user interface, chart, image.series. Through this function, you will be able to get the series of NDVI variation over this region. Instead of image collection, add NDVI. Instead of the region is the region, or instead of the region of interest, irrigated vector defined. And the reducer, I'm gonna get, for example, one statistical operator should be added here. I'm gonna get the average NDVI in this region. So Earth engine.reducer.min, just like this. And the next is a scale 1000. Scale it should be 250, and X property should be system time start. Let's run, and after a few moments you can see a new chart is generating. The chart will show the NDVI variation over the irrigated area. So as you can see, this is the NDVI variation over the irrigated area. As this is an irrigated, there is very low fluctuations in this area, and most of the time covered by the vegetation, and that's why you can see such kind of variation in this area. And also there is a peak, but in the rest of the years you can also see that the NDVI never reached to the zero, because the irrigated land over most of the time used for the agricultural activities, because there is an irrigation system in this area. But the rain-fed area typically part of the year actually are excluded from the vegetation cover because they depends on precipitation and etc. So for example, in the basin we can select another part of the basin to see the how NDVI varies in that region. For example, in the upstream, this place, there are some rain-fed areas that we can make a new geometry and see how, for example, NDVI varies in this region. So now let's make a vector layer for the selected area and then see how NDVI varies in this region. So Rainfed sets to from the cropland. I'm gonna select all the rainfed area including value number 3, and then through the self mask I'm gonna get rid of the other pixels or other non-rainfed areas. Rainfed vector layer created like this. Get the rainfed and then reduce to vector. The reduce to vector is very helpful to do this conversion. The geometry will be equal to geometry number 3 and scale equals to 100 meter. So there it is. And let's do the visualization to make sure the rainfed area, the vector layer for the rainfed area created. Rainfed vector. So leave the visualization parameters empty. Rainfed vector. And use the false at the end to avoid automatic visualization. Let's run the rainfed vector. There it is. You can see all the rainfed areas selected. In the next step, we want to see how NDVI varies in this area. The first plot belongs to the irrigated area NDVI variation, and the next plot will be about the rainfed region. Again, user interface chart image.series utilized here. Instead of image collection, we will have the NDVI. The region will be rainfed vector layer reducer earth engine.reducer.men, and scale should be 250, and the X property will be the system time start, the property explaining the time information or data acquisition for the satellite data. Finally, we will have two plots. One of them actually shows the rainfed variation that you can see with higher fluctuations and also more distance between the peaks and also between high and low values. And also we have an irrigated area with a less fluctuations. For example, in irrigated area you can see always NDVI is below 0.2, but here sometimes the NDVI reaches to 0.1. The NDVI value is lower, and also we have a little bit higher fluctuations compared to the irrigated area. Because the agricultural activities in the rainfed area always depends on always depends on the precipitation and agricultural activity or associated with the climatological situation. That's why in the summertime most of the time you can see there is no product here, and NDVI is very low in this region. So that was actually a very short and brief introduction about this useful product. I tried to give you some insight about how to use this product, how to get export, how to actually get NDVI variations or the other variable variations for each region you want. So if you had any question or problem regarding this tutorial, feel free to put your comments, and also the code link is also available. You can compare the codes if in case you had any problem or challenge regarding to the technical analysis here. I hope you like it as much as I did. Thank you for the attention.